Hey guys, George at SoundTraxx here, and this week we're going to do an installation on a brand new model that has just started shipping, the Walthers Proto 2000 SW1200. So let's get started. So as many of you know, the new SW1200 has been shipping to stores now, and they come with one of our competitors' inferior products installed inside. And so today we're going to teach you how to take that out and install a TSU-1100 into our SW1200. Now, as simple as a plug and play would be, of course they have to keep things different, and if they're using these proprietary connectors called the Next 18, which are primarily only used in Europe. So of course they're going to try to put those into models over here because none of the local DCC manufacturers here in the United States offer a Next 18 plug. So because of that, instead of using the 21 pin, we're going to have to take this circuit board out and wire it in. So first thing we need to do is we need to verify and perform a stall current test. And we need to make sure that our TSU-1100, which is rated for up to 1 amp, is going to be sufficient to be able to run the motor. Now, we're going to go ahead and hook up our connections and we'll show you what we did. Now, first off, we connect just a standard DC power pack, and I'm using a standard Bachmann train set power pack connected to the rails. Now, in the lead to the rails, I've connected this multimeter set, and we're going to set this to DC amps. And what this is going to tell us, it's going to tell us what the amperage current draw is when we put the motor on the track. Now, our power pack is already preset to about 16 volts. So when the track power is on, it's actually supplying 16 volts to the rails. So we're going to take our model and we're going to go ahead and put it on the rails, and our model is going to start to move, as you can see. And you can see that it's drawing about 0.24 amps, something like that. But now the key is we want to stall it out. We want to make sure that we're going to draw below 1 amp. So to do this, we're going to gently press on the model until the wheels stop. And you're going to see that we got about 0.65 amps. We're going to let it run again, and then we're going to stall it again, and we're at 0.656. And you can do this several times to verify and test for stall current. But as you can see, at 0.6 amps, we're well below the 1 amp stall current limit of our TSU-1100. So the good news is we can use that TSU-1100. Now that we've performed our stall current test, we're going to remove the shell. Now on the shell, there are actually 5 tabs that you'll need to press in and release from the frame. There are 2 up front, 2 right here in front of the cab, and 1 right here back behind the cab. So we gently grab these and slowly work it out. Now I've already loosened this shell up, and so it just lifts off like that. And here you can see the tabs as they sit on the underside of the shell. Now we're going to pull that out, and you're going to see the 2 wires that are going to the reverse headlight. So we're going to be careful not to pull those loose right now. Now you can see the PCB that's installed, and they've got a mount for a Minikube speaker, and then they have the circuit board here, and all of the wires go up to it. So we're going to take this out. Now to start removing the shell so we can start taking the circuit board out, we're going to remove the light pin. Now on this one, you're going to notice there's only 2 wires going to this long pin. So we're going to go ahead and simply gently pull that out of the connector. We can take that and set that aside, and we will come back to that when we're ready to install the headlight. Now once we've removed our shell, we then need to take a look at the circuit board and identify the purposes of each of the wires. Now on this model, you can follow the wire coming from the rear truck here, and that's the power leads that are going here. So we can simply unplug this and have this ready to be moved out of the way. Now next up right here, we actually have our motor leads. And you can tell because these wires go down to the motor. So once we've identified that, we can unplug this harness. And you'll notice this is actually orange and gray wires. Now next up is the next plug here, and this one, if we follow the wires, we can actually identify that these are going to the front truck. So these again are our track power pickups, so we can unplug that one. So last up is this 6-plug connector here, which has the 2 wires for our headlight LED. Now it won't unplug because of the spacing, so we have to take the circuit board off. So we're going to take our screwdriver. We're going to remove these two screws holding the circuit board in place. We can take that out of the way. Now we can simply unplug the harness and our circuit board lifts away and can be set aside. Now once we've removed our circuit board safely out of the way, now we can take this tape out of the way, and this will reveal all of the wires that we have to solder and where they go. And then we can undo this one. You can see that we've got plenty of wire leads to deal with on all of these. So now what we're going to do is we're going to take our TSU-1100 for EMD2, and we're going to take our Minikube speaker and we're going to install these into the model. So first off, let's start with our Minikube speaker. Now if you'll notice, there's actually an enclosure right here for a speaker. So let's take a look and see what this entails. So we have 4 screws holding this housing in place. And a good idea when you're undoing your screws to make sure you keep everything separated so that way you know which screws are for what purpose. Now once I've removed that out of the way, I can take my housing out, and if you look, you'll see there's a nice place right there for a cube speaker. Well, our speaker comes with the baffle enclosure already on it, and it's held together with a simple rubber band. Now the good news is that you can just simply pop this out of this housing and take the speaker out, set the housing aside, and this will fit right in here just like that. Now we just have to solder the 2 wires for that speaker to the speaker. So we'll pop that out beforehand, we'll wire the wires to it, and then we'll route it back. So let's go to the soldering station. Okay guys, so when we're soldering, the first thing we want to do is strip and tin the end of the wire. So we're going to take our wire strippers and we're going to gauge it out. We're going to strip and tin the end so you can see where I've cut the insulation off. So we're going to slightly twist the wires to make sure that they stay together. We're going to put a little dab of our solder flux right here onto the joint. Now we're going to take our soldering iron. We're going to get just a little bit of solder here on the end of the iron, and we're going to touch it to the end, and you're going to see that wire is perfectly tinned. Now, if you look in comparison, you can see that wire lead is a lot longer than the pad that we have to solder to. The good news is you can always cut this short. So we're going to cut this a little shorter so that now you can see the size of the pin compared to the wire, and it's a lot more close. So what we're going to do now is we're going to take a little bit of our flux, we're going to put it on there. Now here's a little tip for you. When you're working with these small speakers, they have a magnet on them, and so they tend to draw up to the soldering iron, and so you don't want to do that. So what I suggest is you take another tool, just a little pair of pliers or something like that, anything that's laying around, and you can simply use that to hold the speaker in place. Just lay it on top, and that'll help hold the speaker there while we're working. So now we're going to get a little bit more solder on the end of our iron. We're going to take our wire and we're going to hold it to the speaker, and the flux will draw the solder off the end of the iron. And so now we have our solder joint, and you can see that we have a nice clean small joint on the end of that speaker wire. So we're going to do the same thing on the other side here, and then we'll get back to the studio. So now that we've soldered our wires to our speaker, we can simply mount it in place. So again, we're going to take our speaker and simply put it into the housing right here. Now there is a place for the speaker wires to run, and we're going to run those back under the speaker and out the back here, so that way they're not interfering with the mounting of this baffle, but they will allow the speaker wires to come up and out of the way. Now conversely, if you wanted, you could drill a small hole up here and route the wires up and through it. Again, it's personal choice. On this particular case, I'm just going to route them around. So we want to make sure to take orientation to put our headlight facing forward. And remember, our red and our black track wires were routed around this. So we need to make sure to take care to make sure that these wires are located in the openings where they were supposed to be. So now we're all good. So now we can reinstall our screws that hold the speaker baffle in place. Now one other thing I didn't mention was the speaker can be held in place with either some light silicone or a small amount of plastic adhesive. Just make sure that when you're applying any adhesive that you do not get any on the speaker cone itself, or you could damage the speaker. So now that this is all installed, Now we have our wires. We see what all we need to connect. The only thing left is to install our decoder. So we're going to use our TSU-1100 for EMD2, as I mentioned. Now the other thing is, when we're doing our headlights, these are LEDs, and so our decoders are not pre-regulated for LEDs. You want to take a 1,000 ohm resistor and put it in line with each of your headlight and your backup light wires. Now ultimately this can be either wire, but you want to make sure you have one resistor for each LED. Now the other thing is, you'll notice there's actually a blue wire and a white wire, and I would believe the blue wire will be our function common, but we're going to test that here in just a minute. Okay, so the first thing we want to do is we want to be able to mount our decoder. So we're going to take some double stick foam tape. We're just going to cut in a little bit about the length of our decoder. We're going to take this and mount this here to the top of the motor. Now you want to make sure that you have tape thick enough to clear these things. These little shelves can go out of the way if they do interfere, but we don't need to do that. We're going to peel the backing up. Now we're going to take our decoder out of the package, and we're simply going to mount the decoder in place, and we can do that just like that. Now our decoder is held in place. We can work with and around the decoder. We can tie in all of the wires where they need to go, and the decoder will be held in place so we're not chasing it all over the work table. Now, first thing we want to do is we want to go ahead and do these motor leads. Now the motor leads are our orange and gray, and the reason I want to do those first is because we're actually going to replace this harness. We can take our soldering iron and turn the model onto its side. We're going to very carefully just touch the terminal of the motor here. We're going to melt the solder, and we're going to pull that wire loose. We're going to do the same thing on the other side and desolder the orange wire. And the reason we're going to do that is because then we can take the orange and gray wire directly from our decoder to the model. The biggest thing to point out though is make sure you remember which side is orange and which side is gray, because if you get the polarity of the motor backwards, your model will run in the opposite direction. So knowing this side was orange, we're going to go ahead and grab our orange wire from our bundle of wires here. We're going to take this, we're going to run it down the side, and then we're going to measure about how much we need, and that should be all the wire we need right there. So we're going to take this, we're going to grab our wire cutters, we're going to cut the excess wire, and we're going to store that for future use. Now with our shortened lead, we're going to do the same thing. We're going to cut and tin the wire. So we're going to go ahead and trim the insulation. We're going to slightly twist the wire up to make sure that there are no frayed ends. We're going to take our flux, we're going to put a little bit of flux on the end of the wire here to make sure that our solder will flow properly. And we're going to grab our soldering iron lead. We're going to tin the end just like that. Now again, we can trim the length of this to be a little shorter so that way we have a very nice clean joint once we're done. Now in this case, we're going to take our tweezers and we're going to hold the wire in place because we're working in a tight location here. We're going to put a little flux on this joint, make sure everything goes where it's supposed to. Now we're going to take our soldering iron, reach in here, and this is tight fit this is tight work here, so be careful when you're working. And there's our solder joint. Now we're going to do the same thing with the gray wire. Now when we're doing this, we want to be careful and make sure that the metal of these wires are not touching this metal frame here, or you potentially can run into a short circuit. Get a little solder. We'll go ahead and make our joint just like that. Now alternatively, if you wanted to or felt more comfortable, you could always take the original orange and gray wire and cut them and then just simply solder your two wires together. Now the next thing we're going to do is we're going to attach our power leads for the track. So we're going to take our black and red wire here and the black and red wire from the from the rear truck, and we're going to combine these together and attach them to the red and black wire on our decoder. So in order to do that, these wires can go all the way over here so that we can make our connections in this area. So we're going to go ahead and cut these right behind the connector, just like that. Now in this case, when we strip the insulation off of the wire, we're going to wait because we're going to be joining this with these other wires, and so we're going to do a three-way connection here. So we can just simply peel the insulation off on these to start with. Now this other side, we have plenty of space to deal with, but we don't want to leave ourselves too short, so we're going to go ahead and cut about an inch or so off of the end of the wire. You can kind of see how much that is right there. Let's set that aside. Now again, we're going to strip the insulation off on the ends of each of these wires. Just like that. Now the last thing before we make these joints is we're going to grab the red wire off of our decoder, and we're going to do the same thing. But remember, we don't have to go very far. And one of the key things is you don't need to put a whole lot of tension and pull on these wires. They're press fit in. If you put too much, they can pull out, since there's not a solder connection on it. So when we're doing our connections here, we want to make sure that we have plenty of room to work with, but not so much that we're going to be tugging on the wire. So in this case, we're going to leave about 2 inches on the end of this wire. We're going to go ahead and cut that short. And again, we can do the same thing where we can strip the insulation off the end of the wire, just like that. Now we're going to do the same thing with our black wire. So again, about 2 inches or so. Cut the wire, and then we're going to strip the insulation off. Okay, so now it's as simple as making a connection between all 3 black wires and all 3 red wires. But the key thing we want to make sure we have first is heat shrink tubing. Now heat shrink tubing is tubing that will shrink when it's heated, and this helps protect the insulation on the joint to make sure that it's not going to touch anything arbitrarily. Now SoundTraxx offers a package of heat shrink tubing in various sizes to match the wire that you're working on, so be sure to get that from your local retailer or online at SoundTraxx.com. Now we're just going to cut a small piece of insulative tubing here, and we're going to slide that over one of the wires, and I'm going to pick the side on the decoder. Now what we're going to do is we're going to take our 3 wires. All of these are going to come together. We can take 2 wires and twist them together first. So our 2 track power wires, we're going to go ahead and twist those insulations together to make a physical bond. Just like that. Now we're going to take our decoder wire, and I want a little bit more insulation cut off here. And we're just going to add it to the twist. So we're going to take these 2 wires and our decoder wire, and then all 3 of those are going to get twisted together in a 3-way connection, just like that. Now we've got a nice connection there. So we're going to take our flux, we're going to put a little bit on the joint, don't need quite that much. Get our soldering iron, put a little bit of solder on the end. We're simply going to solder those wires together. Now all 3 of these wires are soldered together, but what we can do is, since the insulation's on this side, we can take this and kind of bend the wire in such a way so now we can take our heat shrink tubing and slide it over the joint to form our insulation. Now if your solder joint ends up being too long, you can always trim it. Just make sure you don't trim it too much, because if you trim it so much that you lose your connection, you got to do all this over again. So now once my heat shrink tubing is in place, I'm confident that all of my bare metal is covered. Now I'm going to take the barrel of my soldering iron, and I'm going to kind of hold it over the heat shrink tubing a little bit, just like this. And you don't want to use the tip, because you don't want the oils or grease from the rubber tubing to get onto the tip and potentially contaminate your joints with your solder. So we're just going to use this a little bit here, and you can kind of see it starting to shrink down a little bit. And there's our connection. Now we're going to do the same thing for the red wires. Now the last thing is we can connect our 2 speaker wires together. Now, there's a couple of things. One is, if we had done this, we can simply take these wires and solder them to the speaker and put them into place. But we hadn't opened the decoder yet, so in this case, we're going to go ahead and join these two sets of wires. Now, purple wires for the speaker, you'll notice the color is exactly the same because when we're using one speaker, polarity doesn't matter. So we're going to go ahead here and we're going to measure out approximately how much we would need. And again, remember, a little more is fine. So we're going to cut these speaker wires from the speaker about here. I'm going to take these purple wires out of the way. And then the two speaker wires coming out of the decoder, again, we don't need to go very far. So we're going to cut those at about 1.5 inches or so in length, just like that. We're going to take our excess wire and hold it off to the side. Now, when we're done this, we're going to go ahead and strip the end of the wire, and we're going to make our solder joints, and then we're going to heat shrink tubing to insulate. So let's go ahead and do that. So the first one. Okay, now we've put our heat shrink tubing on the wires. Now we just need to make our joints. So we're going to go ahead and match these up, twist the wires together, just like that. We're going to put a little bit of our flux on the end. Okay, now we're going to take our heat shrink tubing. We can trim this a little bit. I'm going to take our heat shrink tubing and slide it over the joint. Take the barrel of our soldering iron and we're going to heat this up to insulate the joint. Just like that. Now we're going to do the other side. Now in this installation, we're not going to use the green and the brown wires. So we're going to go ahead and trim that short, but not so short that we can't go back and use them later. Now we can take these and slightly tuck them back. We can go ahead and tape some of this out of the way, and then we can go test run our model. So we're just going to take some tape. In this case, I've got some Kapton type tape, and we're going to go ahead and tape these down to hold these wires out of the way, just like this, to help make the installation look a little cleaner. Okay, now we've got our wires tucked away. We just have the 4 wires left for our headlight, backup light, our function common, and the green and yellow striped wire for our stay alive capacitor, which we'll install here in just a minute. Now at this point, we can go test run and verify that we have our motor polarity, we have our speaker hooked up correctly, and so forth. So let's go for a test run. So now we're about to test run our model, and when we do this, we want to make sure these wires do not come in contact with our rails. So we're going to very carefully take this model, we're going to put it on the track, and as you can hear, we've got our model starting up. So we have sound, we have control under address 3. We're going to move forward, and our model is moving in the forward direction. We're going to go in reverse. Our model's running in the reverse direction. So you can see that everything has been wired up correctly. Now, in order to determine the polarity of our wires, to make sure that the blue wire is in fact our blue function common, aka the plus lead, and the white wires are negative lead, we're going to build a quick little homemade LED tester out of this 9-volt battery and a 1000 ohm resistor. So all I'm going to do here in this case is I'm going to trim one lead of this resistor short, just like that. Now with this 9-volt battery, all we're going to do, we're going to put a little flux on the outside of one of these terminals, and you guessed it, we're going to solder it right to the battery. Now the reason for this is because now Now we can test our LED from running from the positive to the negative lead, and because this is our negative lead, when it illuminates with our resistor, we'll know the polarity is correct. Okay, now with our homemade LED tester, we're going to go ahead and take these leads off the LED, and we're going to cut the connector off, just like we've done with our other connections. Now we're going to strip the insulation off of these two wires, just like we did in the past. So now we have our two exposed leads. So now we're going to go ahead and take the blue that we believe to be positive, and we're going to touch that to the positive side. Now we're going to take the negative side and we're going to touch it to the other lead of the LED. And as you notice, the LED illuminates. So that means our polarity is correct. So this blue wire is going to go to our blue function common. The white wire on the front LED is going to go to the headlight. So now we've got our white wire, and in an effort to keep things neat, we're going to go ahead and fish this through the tape that we've applied to keep all our wiring neat. And this is where tweezers become one of my favorite tools. We're going to grab that wire, we're going to put it through the second side of this tape. And once we come through, we can simply pull it through. Now again, remember, you don't want to go too tight because you don't want to put too much tension on that white wire by the connector. So now with our wire here, we see that we have this wire right there. You can see that we can actually even cut this a little shorter than we need to, because you can see where they cross. So we're going to go ahead and cut this wire right there. We're going to take our white wire from the decoder. We're going to cut it about there, just like that. Now we're going to do the same thing we've done with all of our other wire connections, is we're going to strip the insulation. Okay, now that I've stripped the insulation, we're going to go ahead and tin the ends. So we want to slightly twist this wire to make sure it's clean. And we're going to do the same thing over here to make sure it's clean. And we're going to go ahead and tin the ends of these wires. Now we're going to add our resistor for our LED. So the first thing we want to do is we want to take one of our leads of our 1000 ohm resistor, and we're going to cut it short. So that way we don't need a whole lot of space on there, and you also don't want a whole lot of exposed metal, because if we left this entire lead, that'd be an awful lot of exposed metal to be inside the model. So what we're going to do is we're going to go ahead and take our LED and we're going to solder it to the wire. So we're going to put a little bit of flux on the end. Grab our soldering iron. And we're going to line these up. And we're going to let the flux do the work for us. So there we go. We have our solder connection. All right, now we're going to take our different size of heat shrink tubing and we're going to slide this over the entire assembly here, because we're going to go ahead and insulate everything in one fell swoop. We're going to slide it over. Now we're going to shorten our lead on this side, and we're going to go ahead and solder our wire to this. So we're going to go ahead and put some flux on here, get some solder. And we've got our joint made. So now once our joint is made, we can take our heat shrink tubing, we can slide it over the entire joint, and then now the barrel of our soldering iron, we're going to shrink this tubing down. But again, we want to make sure that it stays in place where you want it. So now with our reverse light, we're going to do the same thing. So we're going to go ahead and cut our connector off, just like we did in the past. Now this time we're going to take the white wire from the light and go to the yellow wire on the decoder. So this is the one we need to have a little bit of fluctuation or a little bit of play, because we want to be able to remove our shell if we need to get into it. So we're going to need just a little bit more wire available. So we're going to go ahead and I think this should be enough wire there, somewhere right around in that. Now remember, we're going to add the resistor in here in just a minute too. So now that we've made our cut, we go ahead and strip the insulation off of the end of the wires. Okay, now we're going to grab our other resistor and we're going to trim the lengths again. This time I'm going to go ahead and pre-cut both sides. Ultimately, it doesn't matter. So now we're going to go ahead and tin the ends of the wire. And we're going to solder and tin the end of the wire. This is where you have to take care not to reach into the plastic shell, because we'd hate to accidentally touch the side of the body shell and accidentally melt the plastic. So now we have our leads. Now we're going to get our piece of shrink tubing. We can slide it over one of the wires here, just like that. Now we're going to get our resistor. Now we're going to solder to one of the wires. And then we're going to go ahead and put some flux on the other side. And we're going to solder to the other wire. All right. Now that the solder joint is made, we take our heat shrink tubing and we slide it over the joint, again making sure we're fully covered, and we're going to heat shrink or shrink the tubing. All right, so we're almost done. So the next thing we're going to do is we're going to take our green and yellow striped wire and our blue wire, and we're going to run it through. Now the green and yellow striped, as I mentioned, is for our stay alive capacitor, which we're going to add. So we're going to go ahead and feed this again through our tape so that everything stays bundled close together and clean. And we're going to mount our stay alive capacitor up here in this area and pull this through. Now we're going to take our blue wire and do the same thing. So we're going to go ahead and feed it through. All right. And again, we want to make sure we have just a little bit of a loop down here so we're not putting any tension on the connector that's inside the decoder. So we're going to go ahead and push this through the tape here. And we're through. So now with our resistors in place, we have 3 wires that we need to attach to the blue wire. So what we're going to do, since we have a lot of excess blue wire, we're going to go ahead and cut about 2.5 inches off of the end of the blue wire here, just like that. Now we're going to go ahead and set this aside for a second. We're going to add in our capacitor. Now our stay alive capacitor that comes with it is a 220 microfarad 25 volt capacitor. Now this is designed to help keep the decoder alive for about half a second or so during the millisecond losses of power. So usually a 220 microfarad capacitor is going to be enough power to keep the decoder alive. So what we're going to do here is we're going to again trim the insulation off the end of this blue wire. We're going to put a little bit of flux on the end, and we're going to tin the end of the wire. Now the next step is we're going to solder to the positive lead of this capacitor. Now when you look at the capacitor, you can see that there's a white stripe here with a giant minus sign in the middle of it. And that's telling you this is the negative lead that corresponds with this right here. So we're going to solder the blue wire to this side. So the first thing we want to do is we want to take this and hold it in place so that it doesn't roll all over the round with it, all over the table. Now we're going to take some flux, put it on the end of the wire, and we're going to do exactly what we've done, is we're just going to solder it right to that lead. So let's get some solder on the end of the soldering iron. We're going to mount it up next to it. And there you go. Now we're going to take our heat shrink tube and we're going to slide it over the end of the wire. And then we're going to slide this over this joint to again help protect and insulate the joint. Just like that. Now we take our soldering iron and again the barrel, and we're going to shrink it down in place. So the next step is we're going to take our green and yellow wire and we're going to solder it to the negative side of our stay alive capacitor. So we're going to go ahead and cut the wire. We're going to remove about 3 inches off of there. Now before we place the wire, in this case we want to put the heat shrink tubing over the wire first, because once we make the joint we can't put the heat shrink tubing on it again. Now we're going to strip the insulation off of the wire here, just like that. Slightly twist. Now we're going to take our flux, we're going to put a little bit on the joint here. Now we're going to get our solder. We're going to tin the end of the wire again. Now we're going to solder to the negative lead of our capacitor. So this is where we're going to put a little bit of flux on the joint. So now we're going to get our tweezers and we're going to make this solder joint to the other side of our capacitor. So we're going to get a little bit of solder on the end of our iron. And once we have that, we can make our joint. Now you see that we've made our solder joint. We slide the tubing over the connection. All right, and then we can heat it up and shrink it in place. So now the plan is to put the capacitor right here so it's tucked up and out of the way. So now all we need to do is take our blue wires, one from the headlight, one from the backup light, and one from our capacitor, and one from the decoder, and tie all 4 of those together. So we're going to follow the same procedure we've done in all of these other wire connections. We're going to strip the insulation off of each of these wires. We're going to pick 2 of them this time and we're going to put our heat shrink tubing over them. So what I'm going to do is I'm going to select the blue wire from the decoder coming under the tape and my blue wire coming from the backup light. I'm going to put that over these 2. And the reason for that is because with the shell needing to be removable, this will give me a little flexibility once I put the shell back on. And these 2 can move together because there's a little bit more flexibility, and these 2 will be fairly tight and close together. So now once these wires are through, now we can take our wires and twist them all together. Now, just make our solder joint. We're going to put some flux on here, and then we're going to get our solder on the iron, and we're going to make our joint. And there you go. So now, again, we can trim the excess length of our twist here. And now we can take our wires, fold them together, and slide the heat shrink tubing over the joint. And then we're going to shrink down our tubing. Well, now that we've finished our solder connections, we're going to go ahead and test it, put it on the track before we button her up. And again, make sure that you do not let anything loose, like the capacitor or anything like that, touch that track, because that can cause problems. So we'll go ahead and lightly set the shell on top here for the moment. So let's go ahead and move forward. We're going to turn on our headlight. Our headlight works, as you can see here. We're going to move forward, come to a stop. We're going to change direction, and you're going to see that the backup light is now on. So our lights work. We're moving in both directions. So now all that's left is to button this thing up and tie it in. So to do that, first we're going to cut a small little piece of foam tape to help mount the capacitor and hold it into place. So we're going to take our tweezers. We're going to put this right here on the back of this light housing, or I'm sorry, the speaker housing. We're going to peel the backing off. Now we're going to take our capacitor. We're just going to tack it into place. Now that leaves a few wires up and loose. So this is where we can take our tape, and again, we're going to tuck this up and away and make sure that everything's off the drive line, and make sure our wires are tucked away to make sure they're not going to interfere with the shell or anything like that. So now we're going to take the black piece of tape that we had there before, and we're just going to slightly let this set over the capacitor and over these wires here to hold them in place. Now what we could do is, if you wanted, we can actually take another piece of tape and mount it here. I don't know that that's necessary. So we'll go ahead and take this, we're going to set this down, we're going to put the shell back on. And this is where you want to make sure that all your wires are away from any joints or anywhere that they would potentially be interfering. All right. Now once we've got everything back together, we'll just take it for one last test run just to make sure that everything's good to go. We got our headlight, we got our backup light, model moves, we're not hearing any strange sounds or wires hitting the drive line. So we're done. Now once we've got our decoder installed, the first thing we need to do is make sure our prime mover matches. Now on your packaging, inside you're actually going to see a few CVs and some sample lists, and what we're going to be looking at right here is the prime mover CV select CV123. Now this is a 12-cylinder 567 prime mover, so according to my chart we need to set CV123 to a value of 0. So let's do that. You're going to instantly hear it start back up, and you're going to hear the prime mover as it has changed now to the 12-cylinder 567. So this is why we use the EMD2, is because it has this correct sound on the decoder. Now guys, that's everything. That's all the installation is. So I hope this was helpful for you guys that are wanting to attempt to put the Tsunami2 into these Walthers SW1200s. Also, these tips and principles can be used with any other model that you would be doing a decoder installation into. So be sure to check out the installation guide for other tips and hints. Now, I'm sure many of you guys noticed this is an undecorated model, so be sure to stay tuned to our Instagram channel to see what we turn this into.